Yeah. Hi all. So today is our seventh session, and today we're gonna do some exercises related to chapter 12, which is about inventory management. And today we have four problems, all related to inventory management, and we're gonna do it in Excel. So start from problem 1. We read the problem first. Point A. So here we have Super Boober as a restaurant, and they need one of their main ingredients, the super corn, and to determine the ordering policy, the restaurant has identified the related costs, and the super corn price is 15,000 rupiah per kilogram, and annual carrying costs. Okay, so the price is 15,000, right, per kilogram, and then the annual carrying cost per kilogram per year is 25% of the purchase price, which is 15,000. So we have 3,750 rupiah as our annual carrying cost or holding cost, symbolized with age. And then the other info is, whereas the ordering cost is 50,000 per order. Okay, ordering cost symbolized with S. So first here I want to talk about the terms. Basically, carrying costs have the same meaning with holding costs and inventory costs. They are symbolized with age, and the other terms is ordering costs. It has the same meaning with setup costs, but the difference is setup costs, we use this term in production. Okay, while ordering costs, we use it when we buy our ingredients or materials from supplier. Okay, next, and they estimate that the following demand of super corn is 1,600 kilogram per week. So that's the demand per week. Okay, estimated demand per week. While we have to convert it to annual demand, so we got the D. And for annual demand, we just multiplied the weekly demand with 52 weeks, because in a year we have 52 weeks. So we got this number, 83,200, by multiplying 1,600 by 52 weeks. Okay, so we have annual demand now. And the questions are: point 1, what's the economic order quantity or EOQ? So to find the EOQ, we have to use this formula. Okay, square root of 2 times D times S and divided by H. So D is the annual demand, and S is for the ordering cost, and H is for the carrying cost or holding cost. And all of these components, we already have the info, okay, from the problem. Here we just input it in the equation. Okay, the yearly demand or annual demand is 83,200, and then multiplied with the ordering cost, which is 500,000, and then divided by the holding cost or carrying cost. And then here we got 4,710 kilogram. We just rounded it up, okay, or maybe it's just let it be like that. Okay, so the EOQ for this case is this number, okay, and the optimal quantity order is when the carrying cost or the holding cost is equals to its ordering cost. And then next, question number 2 is how many times the restaurant should order in a year. So the number of ordering. And it's symbolized with n. And to find how many we should order to the supplier is by dividing the annual demand, which is this number, divided by the EOQ, which we just calculated in point 1. So we just we get this number by dividing 83,200 divided by the EOQ, and finally we get this number, okay, and we just rounded it up. So in a year we order to the supplier as much as 18 times. Next, to question number 3 is what's the number of days in between orders. And here the assumption is in a year we have 52 weeks, which is equals to 365 days. Okay, so that's they're asking for the t, and to find the t we have to divide the number of working days divided by the n, which is this number, how many we order to the supplier, okay, and the number of working days is the days in a year, which is just like the assumption, okay, 365 days. So to find the t we have to divide the 365 days divided by this, how many times we ordered to the supplier, and we finally get this number, 20.278 days. And for question number 4, what's the total annual cost including the purchase price paid by this restaurant? So basically total cost when in this case inventory management, there consists of annual purchasing, and then holding costs, and also the setup costs, okay. So for calculating the purchasing cost, we get it by the multiplying the price with the annual demand, and then for annual holding costs we get it by dividing the EOQ with 2 and then multiplied it with the holding cost. And also the last one is a setup cost, or in this case we just change it to ordering cost, because we're ordering to the supplier, we're not producing our own materials. Okay, so for ordering costs we get it by dividing the annual demand with the EOQ and then multiplying with the ordering costs. So actually we already have all the info about all of these components, right? The price is this one, and then this is the annual demand, and then for EOQ we have it here in point 1, and also for the ordering costs we have it here, and then this is for the annual cost. We just input it to the equation, and finally we have this number as our total cost. If we're buying the corn, in this case we buy the corn, okay, as much as this kilograms. Question number 5, they ask if lead time is 4 days, what's the reorder point of the super corn? Okay, so the lead time, or waiting time between when we place order to the supplier until that corn is arrived at our company, that's named lead time, the waiting time until the corn is arrived at our place. So what if the lead time is 4 days, and how much the reorder point. So basically, reorder point is inventory level where the company should start ordering corn for restocking. And this one is lead time, okay, waiting time between corn ordered until it received by the owner. And to find the reorder point, we have to multiply the daily demand with the lead time. Okay, so the info, we only have the demand in a week and the annual demand. So to get the daily demand, we just have to divide the weekly demand with 7 days. Okay, so this one, anyway, this is the formula, so you could know which one this referring to. And then just like I said, so we have to divide 1600 units with 7 days, and then multiply it by 4, which is the lead time, okay, 4 days. And the total of a reordering point is 940 kilograms. So when the inventory is reaching this number, we have to place order to the supplier. And then point B, the question is why companies should have safety stock. What are the factors that determine the quantity of safety stock? So the reason why the company should have safety stock is because the safety stock is used to avoid stock out, or stock out is a condition when the company doesn't have enough inventory level to meet the demand. So let's say we have the main stock, you use the main stock to fulfill the demand, and when the main stock is running out, we still have the safety stock to use for fulfill the demand. So that's why we have to have safety stock, because stock out is a cost for a company, because when we have demand while we have no stock, it means we can't fulfill the demand, right? And it becomes our lost sales, and we couldn't generate any revenue if we have no inventory to fulfill the demand. That's why we should have safety stock. And the factors that determine the quantity of safety stocks, there are 3 factors. The first one is average demand. In this case, we have the weekly demand and also the annual demand. The average demand is depend. Maybe you want to know it in monthly or weekly or daily. So it's depend, but it's usually monthly, And then the second one is demand during lead time. So as I said, lead time is the waiting time between the corn ordered until it received by the owner. So during that lead time or the waiting time, there are demands that occur or coming, and that demand that appear during lead time, we should have safety stock as our backup to fulfill the demand which appear during that lead time, because during that lead time it means that we are still waiting for new stock coming. So to fulfill the demand that appears during lead time, we use the safety stock. And then the third one is the lead time itself. Okay, next question, point C is what's ABC analysis in inventory management, and we have to explain it briefly and give an example of the application of this analysis. So this is actually on your book, but let's discuss it a bit. So actually ABC analysis is a method for dividing on-hand inventory, which is inventory that we have, into 3 classifications based on annual dollar volume, from each that inventory. So the example is we have silicon chips. They are maker of super fast drum chips, and they want to categorize its 10 major inventory items using ABC analysis. So the approach is ABC analysis organizes the item on an annual dollar volume. So the worth of those inventory is judged by the annual dollar volume. And shown below are the 10 items identified by stock numbers, their annual demands, and unit cost. So these silicon chips, they have 10 items, and they call it with this number, okay, stock numbers. So each stock numbers represent one inventory, one kind of inventory. And then the solution as annual dollar volume is computed in column 5, which is the annual dollar volume, along with the percentage of the total represented by each item in column 6, which is percentage of annual dollar volume. And then column 7 groups the 10 items into A, B, and C category. Okay, so basically to determine the annual dollar volume for ABC analysis, we measure the annual demand of each inventory items times the cost per unit. So annual demand of each inventory. So here we have 10 items, right? And each items we multiplied it with the cost per unit, which is here the column number 4. And then class A items are those on which the annual dollar volume is high. So the value of the inventory in dollar which high, they are classified as class A. And then although such items may represent only about 15% of the total inventory items, so they are only judged by the annual dollar volume, not the how big they are in the inventory. And they represent 70 to 80% of the total dollar usage, while class B items are those inventory items of medium annual dollar volume, and these items may represent about 30% of inventory items and 50% to 25% of the total value. While those with low annual dollar volume are class C. They are classified as class C, which may represent only 5% of the annual dollar volume, but about 55% of the total inventory items. So, regardless of the size of the inventory in their percentage in their inventory, we instead looking at the annual dollar volume. The larger the amount, the higher the amount, they are will be classified as class A, and the lower the amount in dollar volume, they will be classified in class C or class B. So we have to get the annual dollar volume, we get it by the annual volume, which is the column number 3, times the column number 4, which is the unit cost. And then we just classified them. The higher the annual dollar volume, they will be considered as class A, and the lower it is, they will be classified as class B and C. Okay, next problem number 2. Here we have Reswan Motors as an Indonesian car manufacturer. At its largest manufacturing facility in Bekasi, the company produces subcomponents at a rate of 300 per day, and it uses these subcomponents at a rate of 12,500 per year, of 250 working days. While the holding costs are $2 per item per year, and the ordering costs are $30 per order. And here we have 5 questions. The first one is, what's the economic production quantity So it's before we answer the question, let's discuss a bit about this kind of model of this problem. This is basically a bit different with the first one. The first one is we have to order the material to the supplier. So that's why it's economic order quantity. While in the second problem, we produce the material in our own manufacturing. So we manufactured it on our own, and then that's why we call it as economic production quantity. So it's not EOQ, while in this case we called it as EPQ, and we called it as production order quantity model. There are a bit different but actually the same. Here the Q is still representing the number of units per order, and the H is still represent the holding cost per unit per year, while here we have a T. T is the length of the production run in days, while P is daily production rate, and D is daily demand per usage rate. And here we have a formula for setup cost and holding cost. The difference is when we order the material to the supplier, we don't have this kind of cost, setup cost. Instead, we only have the name of the ordering cost because we order it to the supplier. And then this is the formula for setup cost and then holding cost, and also this one is for the if it's in the EOQ model, it's EOQ, but since it is in production order quantity model, it's Q star with P, because it's the how many units that we will produce, the economic production. It's a bit different though, the formula. In the economic order quantity, we use this formula instead, okay? The square root of 2 times D times S divided by H, while in the production order quantity model, we have to square root number of 2 times D and times S divided by H, but the H is still multiplied with the 1 minus D per P. That's so the difference is in this only, okay? So the first one, let's answer the question. By the way, we have to write down the info given to make it easier. The first one is the daily production rate, which is 300 subcomponents per day, and the annual demand is 12,500 subcomponents. It should not be per year. And then the number of working days, which is 250 days in a year, and then the daily demand rate is 50 subcomponents per day. Okay, we get the number of daily demand rate by dividing the annual demand with the number of working days. And then the holding cost, it's stated in the problem that the holding cost is $2 per item per year, and the setup cost, it should be setup cost, not ordering cost. Setup cost is $30 per order. Anyway, I will revise it later in the problem sheet. It should not be ordering cost, it's supposed to be the product setup cost. Okay, let's start with point A, is POQ. We use this formula so to know how many units we should produce to reach the economic production. We use this formula. All the components is given, the info about all of this component is given. Okay, the demand, annual demand is 12,500 units, and then the setup cost is $30, and then the holding cost is $2, and the daily demand rate is 50 units. Also the production rate in a day is 300. And then we just calculate this number, and finally we have 671 units as our POQ. Okay, next question B, how many production runs per year will be met? So it's the same with the number of order. If the model of problem is like problem 1, but since we are producing it on our own, so the question is how many production runs per year. And it's still the same. It represented with and then the formula is the annual demand divided with the POQ. The annual demand is given in the problem, and the Q star is the number we just calculated in point A. So the annual demand is 12,500 units, and the Q star is this one, 671 units. So just divide them, and finally we have 19 as our number of production which runs per year. So in a year we have to do production as much as 19 times. Next, question number C, what will be the maximum inventory level? So to find the maximum inventory level, we use this formula. Okay, we have to multiply the Q star, which is 671 units, with 1 minus daily production, daily demand divided with daily production. So the Q star is 671 units. 1 minus the daily demand is 50 units, and then the production rate in a day is 300 units. And we have 559 units as our maximum level of our inventory. So it's better for us to have inventory not more than this number. Next, question point D, what percentage of time will the facility be producing components? Percentage of time. So the percentage of time, we get it by dividing the days of production with the days of inventory. So we have to find the days of production and days of inventory first before we find the percentage of time the facility will be producing. So first is days of production, or DOP. We get it by dividing the Q star with the daily production rate. So the Q star is this one, okay, 600, and then divided with daily production, which is 300. Okay, and finally we have 2.24 days as our of days of production. And after we found the days of production, we have to find the days of inventory, or DOI. So to find the days of inventory, we have to divide the number of working days in a year, which is 250 days, divided with N, or the number of production in a year. So we have to divide 250 days with 19 times, and we have 13.42 days as our days of inventory. And finally we have the number of days of production and days of inventory, and now we could count for the percentage of time the facility will be producing. So we have just divide this number with this number, and we have 16.67% as our percentage of time the facility will be producing. Next, the question E is, what's the annual cost of ordering and holding inventory? What's the annual cost of ordering and holding inventory? So since it's production, it's supposed to be cost of production, I guess, and annual cost of holding. So we have to find the annual cost of production, and we get it by using this formula. So the annual demand divided with Q star and then times the production cost or setup cost. The annual demand is 12,500, and then divided with the Q star, which is 671 units, and times the setup cost, which is $30 per order, and we get 559.02 as our annual cost of production. And then next we count for annual cost of holding. We get it by using this formula. So a half of the holding cost times the Q star, and then multiplied with 1 minus the daily demand divided with daily production rate. So the holding cost is $2, and then the Q star is this one, and then we have to multiply it with 1 minus D. The D is 50, and then the production rate per day is 300. Okay, you could see the formula here and where they are referring to, and finally we have $559.02 as our annual cost of holding. It's like the same though. And finally, to find the total cost for this case is this one. Okay, the total cost is, you just have to sum all of the annual cost of production and annual cost of holding. Okay, we're done for problem 2. In here, the problem is Pepperprint is a paper supplier company, and the main product of Pepperprint, which is Bestprint, has the following monthly request. So here we have the table of month in a year from January through December, and then for each month they have each amount of demand. And then another info given is the lead time for Bestprint products is 5 days with a unit price of 20,000 rupiah, and the ordering cost is 150,000, and the carrying cost is 20% of the price, which is 20,000. So 20% of the 20,000. Okay, so the lead time is 5 days, and then the price per unit is 20,000, and also the ordering cost is 150,000, and for the holding cost is 20% of the price. So we have to multiply the 20% with the 20,000, and we got 4,000 rupiah as our holding cost. And Pepperprint is open for 250 days per year. Okay, so the working days is 250 days. And to find the annual demand, we have to sum all of the demand in this table, just sum all of them, and we finally have the number of annual demand. Okay, that's the total of demand in 12 months. And the questions or here we have 3 questions. The first one is, what's the optimal order number for best print? So that's it means we're asked about the EOQ, and just use the usual formula like this one, the square root of 2 times D times S, and then divided with the holding cost. The annual demand is this one, 34,550 units, and then times the ordering cost, which is 150,000, divided by the holding cost, which is 4,000, and then square root of them, and we got 1,610 units as our economic order quantity. So it's best for best print to order as much as this number. And then next question is, what's the total annual cost that must be borne by paper print? So it's about total cost. Remember that total cost consists of annual holding cost, okay, annual holding cost, and then the ordering cost, and also the purchase cost. For the holding cost, we get it by this formula, and for the ordering cost using this formula, and the last one is for purchasing cost using this formula, and just sum all of them. All the components are given the info here, so we just input those numbers into the formula, into the equation, and finally we have this number as our total cost in a year. The third question is, what's the safety stock and the reorder point? We're given more info about the desired service level, and it's 98%, and the Z value is 2.06. Okay, so this is the service level, and then this one, the Z value. But to find the safety stock, we have to multiply the Z value with the standard deviation, and yet the standard deviation is not given yet in the problem. So we have to find the standard deviation using this formula. Okay, but first we have to make this kind of table first. Okay, so we have to make a table that consists of month column, and then the demand for each month, and then the difference between the average demand with the monthly demand, and also we have to this difference to the power of 2 with the, in this column. Okay, so for month and the demand, it's already given in the problem sheet, and then we just have to find this column, okay, these 2 columns. But first we have to find the average demand first. Okay, just like usual, we just have to total in the demand, and then divide with 12 months, because there are 12 months, and we have 2,879 units as our average demand. And then for filling these columns, we have to find the difference. So to find this cell is by using this one, okay, 3,000 minus the average demand, and then same goes with the rest of them. Just we have to find the difference between the demand and the average demand. So for this one is 2,500 minus the average demand, and for this one is 3,000 minus the average demand, and so on and so on. And finally, after we got the difference between the demand and the average demand, we have to give the power of 2 each of them, and then put the result here. So it's we have it by calculating 121 to the power of 2, and just do the same step with for the rest of the data from the first month until the 12th month. And finally, after we have these numbers, we have to sum all of them, and finally we got the sigma. And this number, the sigma, we use it for this equation, okay, to find the standard deviation. So actually the formula or the equation for finding the standard deviation is by the square root of 1 divided with n minus 1. So n is the total of the month or the period. In this case we have 12 months, so the n is 12, and then minus 1, and this part, the sigma xi minus x bar and to the power of 2 is this number. So just put this number into this, and finally we calculate this equation, and we got 232 as our standard deviation. And now we already have the standard deviation, and now we are back to find the safety stock using this formula. Okay, just same with this one. So to find the safety stock, just multiply the z value, which is 2.06, times the standard deviation, and we got this number. After we find the safety stock, now we move to find the reorder point. So to find the reorder point, we use this formula by multiplying the lead time with the daily demand, and then plus the safety stock. While in this problem, it's not stated yet about the daily demand, so we have to divide the annual demand with the number of days in a year. So actually I already count for the daily demand here. Okay, and you can see here it's the total of the demand in a year, and then divided by 250 days, because it's stated that they're working 250 days. So the total of the demand in a year divided by the working days. So we actually already have the daily demand by using that formula that I just said, and just multiply it with the lead time. Okay, so the lead time is 5 days. Okay, so 5 days times 150, and then plus the safety stock, which is 478 units. And here we finally got 1227 as our reorder point. So when the inventory is reaching this number, we have to place order to our supplier again for the replenishment. Okay, done for problem 3. Now we move to the last one, is problem 4. Here we have an auto parts supplier sells Hardy brand batteries to car dealers and auto mechanics. The annual demand is approximately 1,200 batteries. The supplier pays $28 for each battery. So that's become our price, okay? And 1,200 batteries is the annual demand. And then estimates that the annual holding cost is 30% of the battery's value. So the holding cost is 30% of the price, which is 28. And we have $8.4 as our holding cost. And then it costs approximately $20 to place an order. So the ordering cost is $20. Okay. And then the supplier currently orders 100 batteries per month. So actually we have 100 as our EOQ, let's say our initial EOQ or Q. And then we have to determine the total cost for the current order quantity. So the first one, we have to find the total cost for current Q, which is 100 units. They are asking how much is the cost if we are using 100 as our order quantity. Just like the previous one, we have to sum all of the costs, like ordering cost, inventory cost, and then the purchase cost to find the total cost. And still using the same equation like this one, okay, and all the components, all the number for the components is already given. For Q star is 100, and then for the H or the holding cost or inventory cost or carrying cost is $8.4, and then for the annual demand is 1,200 units. Okay, and then Q is still the same 100, and the ordering cost is $20, and then for the price is $28, and then for the annual demand is 1,200 units. And then finally after we count for this equation, we have $34,260 as our total cost. So this is the total cost if we are using 100 as our order quantity. And then the next question is we have to determine the economic order quantity. So we have to find the new Q. We have to find the new EOQ. Still using the same formula like previous problem, like this one, and just input the number into this equation, and finally we have 76 units as our new EOQ. So now we have two Q, we have two quantity order quantity. And now at point C, we're asked how many orders will be placed per year using the new EOQ, which is 76 units. Okay, so the number of orders, if we are using 76 as our order quantity, it becomes the annual demand, which is 1,200 units, divided by the Q star, which is this one. We are using the new EOQ, okay, 76. And we have 16 times if we are using this number as our order quantity. And then the last one is we have to determine the ordering, holding, and total inventory cost for the EOQ. How has ordering cost changed, and holding cost, and then the total inventory cost? So actually we're being asked about the total cost, the difference between the old Q with the new Q. So just like before, just for total cost we have to sum all of the ordering costs, okay, inventory cost, and then the purchase cost. Still using the same formula, but the difference is in Q star we're not using 100 anymore, but we're using the new EOQ, which is 76. And then for the rest of the components still have the same number. The difference is just in the Q star, okay, change the 100 with 76. And now we have $34,235 as our total cost. So now the difference is if we are using 100 as our order quantity, this number is our total cost. But if we are using 76 as our order quantity, we have this number as our total cost. And if we look at them and we compare them, the lowest one is if we are using 76 as our order quantity, so it's better for us to use this number instead, so we get the cheaper cost, the lowest cost. Or if you want to break down each one of them, okay, for the ordering cost itself and or the holding cost or the inventory cost, just separate the calculation, okay. This one is just the total cost. Well, actually it's all for today's session. We are done, and thank you.